Dear students, I am going to talk about the degree of static indeterminacy. Degree of statically indeterminate structures are those structures which cannot be analyzed with the help of equation of static equilibrium alone. These structures are also known as hyperstatic. The number of additional equations based on the compatibility of deformations necessary for the solution of the problem is known as the degree of static indeterminacy or the degree of redundancy of the structures. Suppose there are 5 unknowns in a structure. So 3 can be found out with the static equilibrium, 2 cannot be found out. So therefore 2 equations can be formed with the help of deformation equations, and therefore its degree of static indeterminacy will be 2. Like the total degree of static indeterminacy may be a degree of external indeterminacy, which is DSE, और दूसरा degree of internal indeterminacy, DSI. Therefore total indeterminacy DS will be sum of these two. So DSE for plane structures is equal to R minus 3, and DSE for space structures will be R minus 6, where R is the number of reactions. Now DSI is the internal and DSC external. So now we're going to discuss about what the stability condition for stability condition for the pin jointed structures internally. If M is greater than 2J minus 3, the structure is unstable. The member of the structure, total member of the structure, this is more than 2J minus 3, with J is the structure is unstable. A pin jointed frame is statically determinate internally if it has just the minimum number of members M dash required to preserve its geometry. Pin jointed plane frame if m dash is equal to 2j minus 3, pin jointed a space frame, m dash is equal to 3j minus 6. DSI for pin jointed plane frame is equal to m minus 2j minus 3, or DSI for pin jointed a space frame is equal to m minus 3j minus 6. Now come for the stability conditions. Internally, stability conditions internally for pin jointed frame. If m is less than 2j minus 3, this is the structure plane frame is unstable. Similarly, if m is equal to 2j minus 3, the structure is stable and statically determinate. If m is greater than 2j minus 3, the structure is over stiff and indeterminate. Determination of static indeterminacy by number 1, you can by Henderson's rules, and second with the method of joints. Henderson's rule is that is also known as cantilever method, cantilever tree method, tree method. Henderson provided a simple system to find degree of indeterminacy for Henderson provided a simple system to find degree of indeterminacy for rigid jointed frames. First of all, the joints are made rigid by providing extra restraints R dash. Then the structure is cut to make it open tree-like determinate structures. Degree of indeterminacy can be found out. DSE is equal to 3C minus R dash for plane frame. DS total. DS is equal to 6C minus R dash for a space frame where C is number of cuts required to make the structure tree-like. R dash number of constraints added to make rigid. Now I am taking few examples. I am taking to solve by Henderson's rule. So there is a simple one-way frame. I want to find out the total indeterminacy. So if you are using by Henderson rule, I can cut it in such a way that it make tree-like structure. So now I am cutting here. If I am cutting the first number, then this is a cantilever structure, determinate. This is also cantilever structure, determinate. So it's become tree-like structures. Now according to Henderson's rule, ds is equal to 3c minus r dash for plane frame. This is a plane frame. So number of cut, only one we have cut. There is no restraints. All joints are rigid. So we are not making any restraints. So it is 0. So ds total is 3. Now external DAC is r minus 3. Here reaction is 6. 1, 2 and 3. It is similarly here also R4, R5 and R6. So total reaction is 6. So therefore 6 minus 3 is equal to 3. So the total degree of indeterminacy is 3. External is 3. Therefore internal indeterminacy is 0. Same way I am taking the other examples. I am taking the two-bay frame, single frame having, say this joint is pinned. Now I am going to find out what is the number of degree of static indeterminacy. Therefore I must make this joint as rigid. So once I am making the rigid, I have to introduce one moment. Moment will be introduced. So restraint is 1. Also there is a formula to find out the R dash is equal to sum of member meeting at the joint minus 1. So here the two members are joining, therefore 2 minus 1, there it will be 1. So now this become a rigid, this is same as it become like that, then I am cutting it, it's one cut. So ds is equal to 3c minus r dash. So 3 into 1 minus 1. So degree of indeterminacy is, total is 2, dse is 3. So dsi will be 2 minus 3 is equal to minus 1. So this is the internal indeterminacy, there is minus 1. In this way, different examples, two-story frame, suppose there is two-story frame and this is the two-story frame, and making this is the hinge here. So again r dash is equal to 1. Why? There are two members are meeting here. Therefore I can cut it to make the structure. Here cut and the here cut. So there is 2 cuts. Reaction is 6. Therefore, ds is equal to 3c minus r dash. 3 into 2, 2 cut minus r dash is 1. So this is 5. The dse is equal to r minus 3. R is 6 minus 3. So this is 3. So dsi is 5 minus 3 is equal to 2. So degree of internal indeterminacy is 2 and degree of external indeterminacy is 3 and total is 5. So this way you can, how many forces? There are 5 forces extra required in addition to equilibrium condition. So in this structure there are 8 forces. 8 में 3 external, 6 external and 2 internal forces are there. In this way you can find out the. Now take the another example. This is roller and this is hinge. Now I am going to use the Henderson rule to find out degree of static indeterminacy. So I can first make the non-rigid joints as a rigid. So this is, there is 2 reaction here, R1 and R2. This is hinge. So if I am going to make a rigid, therefore one external reaction we have to put it, then it will be fixed. So making a tree-like structure, it will be fixed. Here there is one reaction only, one reaction. So here there will be, if I am making the joint, there will be 2 support. Then it will be, a support will be fixed supports. And this is already fixed. Now I am to cut to make tree-like structures. So I am cutting here. So it is tree-like. I am cutting here. It is still this is fixed. So I am also cutting here. So we are cutting 3 cut and this become a tree. This is tree. This is fixed. This is also tree. This is fixed. This is also tree. This is fixed. Tree. So this is for all the tree-like structure, means determinate structures. How ds will be 3c minus r dash, and this is the plane structure. So how many cuts I have made? 3. How many restraints? 2 and 1. There are 3 restraints. So there are 6 degree of indeterminacy total here. How many external indeterminacy? R minus 3. How many are? 3 and 3, 6, 7 and 2, 9. There are 9 minus 3. So there is 6. So internal indeterminacy 6 minus 6, 0. Example of support condition different. One is the hinge, other is the roller support. And taking second, here the internal hinge is also being provided. So this is hinge providing. Now if I want to make the tree-like structure, then we have to make this rigid. So there are 2 members. So R dash is equal to 1 here, R dash is equal to 1 here, and this will be make fixed to make tree-like. Then if I am making fixed, there are 2 reactions. So 1 I will add if I am making fix. If I am making fix here, there is 1 reaction. So I am adding 2. So the D I am now cutting to to make the tree-like structures. So we will cut to ds is equal to 3c minus r dash. So 3 into 2 minus r dash to 3 and to 5. So this is 1. DAC is r minus 3. So there are 3 reactions, 1, R2 and R3. There are 3 reactions. So 3 minus 3, DAC is 0, DSI is equal to 1 minus 0 is 1. This is the, I'll find out now. Another example, if I am taking the framed structures. Suppose this is the face, this is a hinge, and suppose this I am making hinge, and so how to find out the degree of indeterminacy? So here there are 3 members meeting. So R dash will be sum of the members meeting at that joint minus 1. So 3 members are meeting. So 3 minus 1 is equal to 2. Here will be 2. Here there are 2 reactions, R1, R2. So if here R dash will be 1. So they all become fixed. Now this becomes rigid, and now you can cut it to make tree-like structures. So ds here is 3c minus r dash. So 3 into 2 minus 2 or 1, 3. So this is 3. DSE is r minus 3. So this is 4 minus 3. 3 or 2, 5. 5 minus 3 is 2. So therefore DSI is 3 minus 2 is 1. In this way, internal indeterminacy and external indeterminacy can be calculated for the frame by Henderson's rule very easily. Now going to find out using going to use the Henderson rule for beams. Henderson rule for beam. We can use the Henderson rule for beam. So Henderson's rule for beam says that the number of support, ds is number of supports removed minus constraints added to make tree-like structure. So ds is number of support removed minus constant added to make tree-like structure. So suppose there is the beam. This is the fix. This is roller and roller and simply supported. So how many reactions are? There is R1, R2, R3, R4. So to make tree-like structures, tree means one edge fixed, other free, these supports will be removed. So how many reactions will be removed? There will be 4. 2 here, 3, 4. 4 reactions will be removed. Therefore ds will be 4 minus. If we are not adding any constraints to make this structure rigid, so that will be 0. So ds is 4. And suppose I am using the here another example. I am taking this is the simply supported. Is simply supported. This is the roller support and internal hinge, roller support, and again simply supported. Suppose this is this. So now I am going to, here is the reaction, R1, R2, R3 and R4. So this is the two members are joining to making the rigid. For that you have R dash is equal to 1 and I have to make tree like, one end should be fixed. I am making fixed, so R dash here will be 1. So this is the fixed, this will be removed. So ds is equal to removed. So how many removed? 2 removed. And how many you have added? R dash 2. So this is the 2. So ds is equal to 2. Degree of static indeterminacy is 2. Externally R minus 3. R is how much? 4 or 2? 6 minus 3 is 3. So dsi is 2 minus 3 minus 1. Another example in the beam I am taking. This is link. So this is hinge here. So the link. So now we're going to find out the degree of state. So we have to make the tree-like structures. I have to make this fix. R1, R2, there is. So I'm making fix and R dash is equal to 1. Here 2 R dash is 1. Here R dash is 1. Here R dash is 2. Here no, nothing. Here is simply supported. The reactions here is R3, R4, R5. So to make tree-like structures, I have fixed this one, and this was the internal hinge. I am making rigid. This supports will be removed and this supports will be removed to make tree-like structure. Therefore, 3 supports removed, 3 reactions removed. So ds is equal to 3 minus how many are there? 3 minus 3. So this is 0. It is a statically determinate structure. It is a statically determinate structure. So in this way, Henderson rule can be applied for the frame as well as for the beams. Now I'm going to second method, which is called method of joints. Method of joints I'm going to use for in-jointed truss. So how to find out this? M plus R minus 2J. Why? M is the one member. Why? There is only member either tension or compression. So there is only one forces. So that's why 1. How many forces it can resist? 1. So it is that side 1. R is the total number of reactions, number of members, number of reactions. J is the number of joints. So this is 2 is because at one joint there is 2 degrees of freedom in pin jointed truss. Now take an example of a truss. One is hinge, another is roller, So this is Pratrus. So here there is two reactions, R1, R2. Here is one reaction, roller, R3, externally determinate. Now I'm going to find out total static indeterminacy. Either this is a determinate structure overall or indeterminate structure. Now all jointed are pin joint, pin jointed, all are pin joint. Now the ds, according to ds, is m plus r minus 2j. So how many members? You count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20, 21. So there are 21 members, 3 reactions, minus 2 into j. How many joints? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 joints. So this is 0. So this structure is statically determinate structure. So find indeterminacy, what is the advantage? If it is statically determinate, then we go for the 3 equilibrium equations, sum of horizontal forces 0, sum vertical 0, and sum of the moments 0, and find the requirements. So this is statically we can do. I've heard if it is indeterminate, how many indeterminacies? 2 members, suppose more. Now take the another example in the same. If I'm going to add suppose I'm going to 2 members adding here and here. 2 members हमने added here. So now what will be the ds? ds is m plus r minus 2j. So there 2 members means 23 plus 3 minus joint remains the same 12. So how many? 2. So degree of indeterminacy is static indeterminacy is 2. Means there are 2 members more, and that make the structure stiff. If these 2 members not be, that will be a stable also. But if these 2 members are added, that is the more you are adding, so this is more stiff. So this is the why. So this making more stiff, you can add 2 more members. Now going to take the examples from frame and beams. So let us take the frame cases, and suppose there is a frame as we done by Hutchinson. So now we're going to do by the method of joints. So here the degree of freedom ds will be 3m plus r minus 3j. 3m, why 3m? There is one member is resisting 3 forces: shear, bending, and so here there are 3 forces. So one member resisting 3 forces: torsion, shear, and bending. So that's why it is here is 3. In the previous case, in the pin jointed, one member has 1 force, so 1. In this member there is 3 forces. So there are 3m plus r. This is the plain rigid joint, therefore 3. At one joint, there 3 degree of freedom. Now I am going to solve by method of joints. Here by method of Henderson you will get 3. Now let's see how much it is coming. How many members? 1, 2, 3. 3 members. How many reactions? 3 here, 3 here, 6 reactions. How many joints? 1, 2, 3, 4. 4 joints. So this is 9 plus 6, 15 minus 12, 3. So this way you can find out by method of joints the degree of static indeterminacy can be found out. Externally it is r minus 3, so this is 6 minus 3, 3, or internally 0. So there is only external indeterminacy. Or now going to take the another example. Another example I am taking. Roller, and suppose the hinge here, and we are going to find out by method of joints as well as method of Henderson rule. We are making the method of Henderson rule. Then this will be r dash 1, r dash 2, and we can cut it here, one cut here, one here, and one here. 3 cut to make tree-like structure. So ds will be 3c minus r dash by Henderson, 3 into 3 minus 3. So it is coming as 6. Now the same can be done by method of joints with 3m plus r minus 3j minus r dash. So how much coming? How many members? R dash word, this will be considered as a full member. 1, 2, 3, 4 members. So there are 3 into 4 plus how many reaction? 3 and 3, 6, and 3, 9, and 1, 10. There will be 10 reaction. Minus 3 into j. How many joints? 1, 2, 3, 4, and 5. 5 joints. 5 joints minus 1. So how many? 12 and 10. 22 minus 6. Now taking another example for the frame. This is the frame. And this is hinge. First I am going to find out with the help of Henderson rule, and then it can be verified by method of joints. Henderson rule by Henderson rule, ds is equal to 3c minus r dash. Here r dash is equal to sum of the members minus 1. So how many members meeting? 1, 2, 3, 4. 4 minus 1 is 3. So ds is equal to how many cuts required to make tree-like structure? 1 here, 1 here, and 1 here. So it will be make this tree. These are the branches of the tree, but only is fixed at one point. The rest are like the cantilevers. Similarly here. So we have make 4 cuts. How many r dash? 3. So this is 9 ds by method of Henderson. Now we are using same problem by method of joints. So ds is equal to 3m plus r minus 3j minus r dash. So 3, how many members? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 members. How many reactions? 9 reactions. How many joints? 1, 2, 3, 4, 5, 6, 7, 8, 9 joints. There is the 9 joints minus 3. Over this. So this is 9. So by both the methods we are get a total. Dear students, I am going to take the next lecture on analysis of fixed beam by Mohr's theorem or the area moment method.